Components of a grid interactive rooftop solar PV system. This document provides a comprehensive overview of the essential components that constitute a grid interactive rooftop solar photovoltaic PV system. These systems are designed to efficiently capture solar energy, convert it into usable electricity, and seamlessly integrate with the existing utility grid. Understanding these components is crucial for effective planning, installation, and maintenance of a solar PV system. Here's a detailed breakdown of the key components. 1. PV modules, solar panels. Solar panels, also known as PV modules, are the fundamental building blocks of a solar PV system. They are responsible for converting sunlight directly into electricity through the photovoltaic effect. Times composition. Each panel consists of numerous photovoltaic cells, typically made from silicon. These cells absorb photons from sunlight, which then dislodge electrons, creating an electric current. Times arrangement. Solar panels are usually installed in groups, forming arrays on rooftops or other suitable surfaces. The size and configuration of the array depend on the desired power output and available space. Times efficiency. The efficiency of a solar panel refers to its ability to convert sunlight into electricity. Higher efficiency panels produce more power per unit area, making them ideal for installations with limited space. 2. Grid-tied inverter. The grid-tied inverter is a critical component that converts the direct current, DC, electricity generated by the solar panels into alternating current, AC, electricity, which is the standard form of electricity used in homes and businesses. Times DC to AC conversion. The inverter efficiently transforms the DC power from the solar panels into AC power that can be used to power appliances and other electrical devices. Times grid synchronization. A grid-tied inverter synchronizes the AC electricity it produces with the utility grid's frequency and voltage. This ensures that the electricity generated by the solar panels can be seamlessly fed into the grid. Times safety features. Modern grid-tied inverters include safety features such as anti-landing protection, which automatically shuts down the inverter in the event of a power outage to prevent electricity from flowing back into the grid and endangering utility workers. 3. Circuit breakers and protection devices. Circuit breakers and other protection devices are essential for safeguarding the solar PV system and the building's electrical system from electrical faults and overloads. Times overcurrent protection. Circuit breakers and fuses protect the system from overcurrents, which can occur due to short circuits or equipment malfunctions. Times surge protection. Surge protection devices, SPDs, protect the system from voltage surges caused by lightning strikes or other electrical disturbances. Times isolation. Disconnect switches allow for the system to be safely isolated from the grid for maintenance or repairs. 4. Energy meter, net, gross metering. Energy meters are used to track the amount of electricity produced by the solar PV system, the amount consumed by the building, and the amount exported to the grid. Times net metering. A net meter measures the difference between the electricity imported from the grid and the electricity exported to the grid. This allows homeowners to receive credit for any excess electricity they send back to the grid. Times gross metering. A gross meter measures the total amount of electricity produced by the solar PV system, regardless of whether it is consumed on-site or exported to the grid. In some jurisdictions, gross metering is used to calculate incentives or feed-in tariffs for solar energy production. 5. Module mounting structure, MMS. The module mounting structure, MMS, is the framework that supports the solar panels and secures them to the roof or ground. Times stability. The MMS must be strong and durable enough to withstand wind, snow, and other environmental factors. Times orientation. The MMS allows for the solar panels to be oriented at the optimal angle for maximum sunlight exposure. Times materials. MMS are typically made from aluminum or steel, which are both strong and corrosion resistant. 6. Cables and wiring. High-quality cables and wiring are essential for connecting all of the components of the solar PV system safely and efficiently. Times DC wiring. DC wiring connects the solar panels to the inverter. It must be rated for the high DC voltages and currents produced by the panels. Times AC wiring. AC wiring connects the inverter to the building's electrical panel and the grid. It must be rated for the AC voltage and current of the system. Times conduit. Wiring is typically run through conduit to protect it from the elements and prevent damage. In conclusion, a grid-interactive rooftop solar PV system is a complex assembly of interconnected components, each playing a vital role in harnessing solar energy, converting it into usable electricity, and managing the flow of power to and from the grid. A thorough understanding of these components is essential for ensuring the efficient and reliable operation of the system.